Dear students, how are you? Hopefully you all are doing well. This is Amit Saha, lecturer, Department of Mathematics, Milestone College. Today we are going to discuss about chapter 10Z, that is your integration part. Today especially we are trying to solve some mathematical problem from this chapter. Dear students, hopefully this lecture is very beneficial if you write when you watch the video very carefully. Let's have a look to discuss. So dear students, according to our lesson plan, today our discussion topic is exercise 10Z, and among some mathematical problem we will solve first question number 66, and here is given that our integration, that is the limit is 0 to ln 2 ln 2, and here the function is e to the power x divided by 1 plus e to the power x dx. And to solve these types of problem we have to going first the letting part, because if we actually differentiate this part, I mean the denominator, then we get the numerator. That's why our first thing is the assumption part. So let us assume that our denominator 1 plus e to the power x is z, and if we just derivative of this part, then you will get 1 plus e to the power x dx equal dz, and here we will get very easily e to the power x dx equals to dz, and here two value was for what? For x. So for that two we will going for a calculation. Okay, and what about that calculation? For x there is two values, one is 0 and ln 2. Okay, and what about for y? Here if we just putting the value of 0, putting the value of x is 0, then we will get 1 plus e to the power 0, and we know e to the power 0 is 1. What I want actually try to say here, 1 plus e to the power 0, that should be 1 plus 1, it should be 2. So the value of z should be what? 2. So it not be y, because here is given z, so it must be z. Okay, so z should be 2. Now the value of x, if it is ln 2, then what will be happening? If it is ln 2, then we will get 1 plus e to the power ln 2, and it can be written as 1 plus 2 into e to the power ln, and we know this should be always 1. So what we can find from here? Any idea? Exactly, so it must be 1, so 1 plus 2 should be 3. Clear? So dear students, we get actually finally 3. Now we will just putting these values in here. So after putting this value, what we can say, here is the integration part, where at the place of 0 we will write 2, and at the place of ln 2 we will actually writing here 3, and here we have already understand that this part has been letting as z, and e to the power x dx is nothing but the dz. So do you know what is the integration of 1 by z dz? That is, we have a formula, or we know a formula. What was that formula was? The formula was looks like that, d dx of ln x was 1 by x, and now integration of 1 by x dx must be ln of x plus c, isn't it? So if we just use this formula in here, we will get ln of z, and obviously this will lie between 3 to 2. Then finally we will get ln 3 minus ln 2. So what will be the value of ln 3 minus ln 2? No need to going for the calculation, rather we know log a minus log b is log a over b, so this can be written as ln 3 over 2. So this ln 3 over 2 will be our required answer. My dear students, I think you all can understand how we can solve these types of problem. Okay, let's have a look our second types of problem. So dear students, our next math is question number 68, and here is given the limit is 0 to e to the power square and dx over x into 1 plus ln x. So how we can solve these types of problem? My dear students, if we actually taken this part as z, if we consider it, then after differentiating this part we will get 1 by x. So we will get the rest of the part, isn't it? That's why we will going for our supposition part like this way. So let us assume that 1 plus ln x is z, it is 0 plus 1 over x dx equal dz, and finally we will get 1 over x dx is dz. Now for value, what you have found from here, for x we have two values already, and for z we will get actually the output of that two value for x. And what about that? X, the value of x was 0 and e square, and if we put in here the value of x is 0, then we can understand very clearly that 1 plus ln 0 is 0, that is 1 plus ln 0 is nothing but 1, isn't it? So write down here 1. So what was there? 1 plus ln 0, that was 1 plus 0, so we found 1. And for e square, if we just putting here the place x is e square, we will get ln e square, that means square will come in front, so 1 plus 2 into ln e, that means ln e will be 1, so we will get 3. So for this we will get actually here 3. So now if we just calculating this part, then we can write, after putting all of the value for z at the place of x, we will get dx over x is dz over 1 plus ln x is z. 0 will be replaced by 1 and e square is replaced by 3. So we know, my dear students, 1 by z dz is nothing but ln z, and here 3 and 1 will be remaining there. So we know this upper limit will come first, so ln 3 minus ln 1. So my dear students, from here what we can write, any idea, it can be written as obvious ln 3 by 1, isn't it? It can be written as ln 3 by 1, that is the first thing first, ln 3 by 1, so it can be ln 3, that is the one thing. And you can solve this math the another way, that is we can solve this math by this way, that is ln 3 minus 0, because ln 1 was what? 0, that's why ln 3 minus 0, so we get ln 3. So you can solve by this way or you can solve by this way also. So both of these two will be our required answer. So you can solve the math this way or that way. Clear? Now my dear students, we are going for our next math for our today's lecture. So now it is question number 75, and here is given 0 to 1 plus x over 1 plus x square into dx. That is the question is given, and we need to solve this question. How we can solve this type of problem, my dear students? Exactly, this can be solved by 0 to 1 over 1 plus x square plus x over 0 to 1 plus x square into dx. So we can actually separate this part like this way, because here was 1 over 1 plus x square and x over 1 plus x square. Here this part can be written as what? We all know that ddx of tan inverse x was 1 over 1 plus x square. So now if we integrate this part, then we get tan inverse x plus C. So here was 1 over 1 plus x square. If we integrate this part, that must be what? Tan inverse x, and obviously the part 0 1 will be there. And here we have seen that this is x square and here is x. So if we derivative this part, then we'll get actually 2x, isn't it? I think you can't understand. So ddx of 1 plus x square should be what? Twice x, isn't it? If yes, then we'll multiply here 2, and this 2 will be actually coming there. So we'll get 0 to 1. Here actually I will not writing with this color because 2 and 2 is here. Now x over 1 plus x square dx. What is happening here? We are trying to actually what? Make it the balanced part as the derivative part in here, so that if we differentiate this denominator, we get the numerator. So what is the benefit of it? Exactly, you can understand. We know that if we get the, after derivating or differentiating denominator, if we get the numerator, then we can say it is ln of denominator. So we can write here tan inverse x 0 to 1 plus half, it should be ln 1 plus x square. And since here was the limiting part, that is 0 to 1 will be remaining there. Okay, so we know how this formula has come. We know if we get something like this, that f prime x and here is f of x dx, then we will get ln of f of x. Okay, and actually we use this formula in here and we get our this part. Okay, so dear students, these all are the understanding parts, so you can neglect up to this part. So what we have been found, after putting this value in here, we'll get tan inverse 1 minus tan inverse 0, and here we'll get half ln of 1 plus 1 square, that is 1, minus ln of 1 plus 0. Okay, by putting the value 1 and 0 in here, and now finally we get tan inverse 1, that is tan inverse tan pi over 4 minus tan inverse 0, so tan inverse tan 0 minus half of ln 2 minus ln 1. So after this, what we can get? Can anyone tell me? After calculating, what you can write in here? Okay, dear students, I have writing the last line in here so that we can understand it very clearly. So we get tan inverse is gone, so it should be pi over 4 minus, it is 0, and here it is half and this is ln 2. So what should be right now? We can write here pi by 4 minus half of ln 2. What can be written in this part? Any idea? Just keep it like this way, no problem. So that will be our required answer. So dear students, our next problem is question number 77, and here is given 0 to 1 dx over e to the power x plus e to the power minus x. To solve this types of problem, my dear students, we can multiply denominator and numerator part by e to the power x. After doing that, e to the power x, and if we multiply e to the power x with this part, what we get? We get e power x, it is e to the power twice x minus e inverse 1 and e to the power x. If we just multiply these two, then it should be both are neglected and we'll get 1. And now if we consider this part as z, then what we can write? If we consider the e to the power x part as z, then this question can be written as like this way. Let e to the power x is z, then e to the power x dx should be dz. Okay, and we all know that when these types of letting or assumption part will be coming, then we have to change the limit part again. So changing the limit part, what we can find here is given the limit part is x, that is x, and it has been converted into z, so we'll get the value for z. So the value of x was 0 to 1, so write down here 0 1, and we have here, if we put in the value of x is 0, then e to the power 0 it should be 1, e to the power 1 it will be e. So our integration part should be like this way: 0 will be replaced by 1, 1 will be replaced by e, and here e to the power z dz is e to the power x dx is dz, so it is dz over e to the power x was z, so z square plus 1. My dear students, we know integration of 1 by 1 plus x square or 1 by z square plus 1, this is nothing but the tan inverse z, and here we'll get 1 to e. So if we just putting here the value, then what we can write? We can write tan inverse e minus tan inverse 1, and here we know tan inverse 1 is nothing but the pi by 4, because 1, the value of tan is tan pi by 4. That's why this line can be written as tan inverse e minus tan inverse 1 should be written as pi by 4. My dear students, can you understand the math? Thank you. So that's our question number 77. So let's have a look our last question for this lecture. So my dear students, that is our last question for our today's lecture, and this math is very very important for your upcoming exam in any competitive exam also. So here is given 85 number question. Here is 0 to 4 root over 16 minus x square into dx. How we can solve these types of problem? To solve these types of problem, we have to make it a shape like this way. That is a square minus x square. Then we'll letting x as what? We'll going for the assumption part, that is x should be a sin x, or a means this part, that is 4 sin, say for example theta. If we derivative this part, then we'll get dx should be 4 cos theta d theta, and after this we'll get two values for two limit, isn't it? Exactly. So for two values we'll get two limit, and here is given 0 to 4, so write down here that 0 and 4, 0 and 4 in here. Then what you will get, if we putting here the value of 0, then what we get here, it should be 4 into sine 0, that means 4 into 0, so we'll get 0. And if we putting the exactly, not just a minute, here we have to putting the value of 0 at the place of x, so it should be 0 equal 4 into sine theta, so it should be 0 equal sine theta, and we know sine 0 is sine theta, so the theta should be 0. Okay, again here we have to put in the value of x is 4, so it should be 4 equal to 4 sin theta, and it should be sin theta equal 1, and we know sin 90 is 1. So the value for theta is what? Exactly, the value of theta should be pi by 2. So theta should be pi over 2. Just putting down here at the place of 4. Okay. Now my dear students, just putting here the values. If we put in here the value of 4, then what we can write in here? So since x has been now replaced with theta, so the limit will be also replaced. It should be 0 to pi by 2 root over 4 square minus x, and the value is x is 4 sin theta. Okay, and what about dx? It is 4 cos theta d theta. Okay, now this can be written as 4 square minus 4 square sin square theta into 4 cos theta d theta. Then 4 square, if we take in it as common, then what we can write? One minus sin square theta 4 into cos theta d theta, and here 0 to pi by 2, it should be 4, and 1 minus sin square theta is cos square theta, and for root it should be only cos theta 4 cos theta d theta. Okay, now we will multiply this, then we will get 16 cos square theta d theta. Okay, just write down. Dear students, we will get here 0 to pi by 2 4 cos, so it should be 16 cos square theta d theta. Okay, now here we know a formula 2 cos square theta. We will going for that formula now. So 8 into 2 cos square theta d theta. 8 will coming in front of the integration sign, and 2 cos square theta can be written as 1 plus cos 2 theta d theta. So here 0 to pi by 2 1 d theta, I mean it is only d theta, plus 8 0 to pi by 2 cos of 2 theta d theta. Just we have separated this integration sign for two thing or two part. Here we get 8 and theta 0 to pi by 2 plus 8, and here we get actually sine 2 theta over 2, because it is the basic formula. You know all that integration of cos ax is sine ax by a. Here the value of a is 2. Okay, after putting here the value, we get 8 into pi by 2 minus 0 minus 8 over 2, it is 4, and sine theta into pi by 2, it is only pi, minus sine 0. And now we get finally 8 into pi by 2, it is 4 pi minus sine 0 into 0, because we know that sine pi, that is sine 180, is nothing but the 0, isn't it? And finally here we get this all part as 0, so the answer of it is 4 pi. So the answer of it is 4 pi, and that is our required answer. My dear students, this is the math is very important for our this lecture as well as the in future which lecture is going on, because our future chapters is mainly depending on these types of math. So Try to focus on all the maths, write down the maths when you are watching the video. Hopefully this lecture is very benefited for you. Thank you. That's all for today.